Here's a simple problem to get you introduced into the torsion formula, to understand the basic concepts and stuff like that. So the question asks to find the maximum absolute shear stress in the given rod. The two main equations we need to know is tau max equals Tc over J, and J equals pi over 2c to the fourth. So we have this rod, we have moments going this way, that way, and that way, and that way. We have a given diameter, given lengths. Alright, so the first thing we need to do is basically piece this to find the maximum T. So first I started by cutting here at point 1. And I have my 300, so I copy it. Because I have a 300, on my cut point, I need to balance out this 300 by giving it another 300 pointing in the other direction. So magnitude is simple. The thing we need to consider though is the direction. So because this is going this way, this one's going to be going the other way, and then our signs. So if we draw a convention where anything going this way is the positive x-axis, and then we do our right hand rule so that we curl our fingers and we point our thumb in the positive x direction. Then when we curl our fingers, our curled fingers are going to end up going along with this this 300. That means that this 300 is positive while this one is negative. So our TAC is going to be negative 300. Now if we look at point 2, I just cut it here. So I copy my 300, my 500, and then I just come up with my unknown here to balance out the 300 and the 500. So because we have negative 500 going that way, I need a 300 this way and another 200. And once again, I take this to be the positive x-axis, I point my thumb in that direction, and then I curl my fingers, and my fingers end up curling with this 300 and this 200. That means that they're both positive, whereas the 500 is going to be negative. So my TCD is this positive 200 newtons per meter. And then finally, I end up cutting at point 3, and instead of like going from this end to this end and having to consider 3 different moments, I just decided to cut only at this end and consider the 400. So I have a 400 going this way. That means I'm going to have a 400 going in the opposite direction. And here I consider my positive convention to be in the direction that I cut. So like no matter what, my positive x is going out of the direction I cut. And if I point my thumb in this direction, my fingers end up curling this way. That means this 400 is going to be positive. And so we have TDB equals positive 400 newtons per meter. Because this has the biggest value, so this is a 300, 200, 400, my 400 is the biggest, this means that this is going to give me the maximum torque, or the maximum tau, I apologize, maximum shear stress. So, I plug in my Tmax to be my TDB, which was 400. I plug in my C, which is the radius. C is always the radius, so half of 30 millimeters. And then I need to find J. So J is pi over 2 times C to the fourth. And we said C is 15 millimeters, so that gives me J right there. And I just plug in the J into my equation, and I get tau max equals 75.5 megapascals. And if you don't trust me, you can go back and use the 200 and the 300, but obviously you will see that this will be the highest tau. Pretty straightforward. I think the key that everybody struggles with is understanding where to cut, what the magnitude will be, and whether it will be positive or negative. So right hand rule in this case is key to being able to visualize the direction and the sign.